And if pressure is in Pascal or Newton per meter square, and rho would be in kilogram per cubic meter, G is of course 9.81 meters per second square. Or we can also use 10 meters per second square. This is accepted in engineering calculations. And yung H natin or H sub A would be also in meter. So these are the units that can be used, no, using the metric system of units. Okay. So another type of manometer is a closed manometer. So walang pakaiba dun sa open manometer, only class, no? Itong fluid natin, itong fluid natin naka-enclose yan and it is not exposed or open to the atmosphere. Hence the word closed. No? So to make this YouTube a closed manometer, to make this manometer a closed manometer, no, both of these legs must be attached to two containers or two vessels. So we can see, class, that we have two vessels in here, vessels A and vessel B. Okay. So yan. So yung vessel B contains a fluid with a density of rho A. Vessel A contains a fluid with a density of rho A, while on the other side we have a vessel B that contains a fluid B, no? Okay. So dito sa ating vessel A, meron ng umiiral na pressure ng fluid dyan sa loob. Ganon din sa ating vessel B, meron ng umiiral na pressure dyan. No? Okay, the pressure would be constant in any direction. No? According to yung principle ni, kaninong principle yun? Sino ba yun? No? Yung unang nabanggit natin noon na Pascal, no? Okay. And then yung pressure varies with depth naman, yan na yung isang concept yan. Okay. So makikita natin, no, by observation dito sa figure natin, mas mataas ang pressure doon sa left leg, rather sa right leg kaysa left leg. Dahil mas mababa yung level ng mercury sa right leg. Yung naglalaro lang kasi yung gauge fluid natin yan, parang nagsisiso lang siya. Kung equal ang kung walang difference niyan, kung walang difference ang elevation ng mercury diyan between the legs, ibig sabihin equal ang pressure sa left at saka sa right, no? Equal ang pressure. Okay. But in this case, class, makikita natin by observation, class, na seemingly mas malaki na yung pressure ni PB kaysa kay PA. No? Okay. So, yan ulit ang i-develop natin. Magde-develop tayo ng manometer equation to describe the pressure difference between these two vessels, vessel A and vessel B. So again, following the same line of thinking as we did earlier, we can see that P1 is equal to P2. We're going to arbitrarily choose 2 points that are of the same level. So nakikita natin dyan 1 and 2. And then may pressure na mag-act dito sa point na ito, P1. May pressure din na mag-act sa point na ito, P2. Since they're of the same level, no, it is assumed that they will also have the same pressure. Okay. So P1 is equal to P2. But what is the total pressure at what is the total pressure P1? So ang P1 natin would be PA That's the pressure of the fluid in the vessel plus rho A times G times HA, and then bababa pa tayo hanggang makarating tayo sa point 1 plus rho HG times G times H. Okay. And then sa kabila naman, dito sa right portion, we can see that P2 is the sum of PB plus rho B times D times H sub B. So notice class, yung A sub A saka H sub B are both measured from the center line of the vessel up to the level of mercury on their respective leg. Okay. So again, class, applying now equality, P1 is equal to P2, we can see that we can arrive at the final manometer equation that is PA minus PB minus PA is equal to rho A times D times HA plus rho sub HD times D times H minus rho sub B times D times HB. So this is not class a fixed formula. It is not a general formula for a manometer. No? Okay, this is the manometer equation for this alone. No? So it is uniquely for this configuration ng manometer alone. Because class, this closed manometer can have many arrangements. At kung ganito ang setup, this equation is specific dito sa ganitong setup only. Because we can vary the setup of this closed manometer. So there is no a general formula for this class. Hence, we call this class a specific formula. No? A specific equation for this particular setup of manometer. No? Kaya kailangan i-derive natin yung manometer equation ng kanyang pressure difference. No? Bago tayo mag-solve, i-derive natin. Okay. Yes. Are you still with me, class? Hello?
Yes, sir.
Yes, sir.
Okay. So, naintindihan nyo ba? Ayan. Now, meron akong shortcut method. Saan nyo malaman yung shortcut method? You cannot find this in any book. Because, dahil siguro chamba, I discovered this myself. Kaya siguro nang tagal ko nang tinuturo to. Kasi this is one of my topics in thermodynamics. Okay. At gusto ko i-discuss uli under fluid mechanics. Kasi may kinalaman ito sa flow meter natin later on. Flow measurements natin. So, kailangan may mastery kayo sa manometry. No? O, ganito, yung shortcut ko, this is my own method. No? Yan, meron akong tinatawag na parang sign convention. Mag-start ako at pressure of left vessel. And then, pag bumaba ako, ang equation ko is positive. Pag tumaas ako, ang equation ko ay negative. And then, yung last na, yung i-equate ko yan doon sa pressure doon sa kabilang vessel. So, mag-start ako sa pressure dito sa left vessel. Then, I'm going to go downward. Every time that I go downward, that would be preceded by a positive sign. But every time that I go upward, that would be preceded by a negative sign. And then, i-equate ko yan doon sa pressure, doon sa kabilang vessel. Okay. So, let's try. No? Okay. Mag-start ako sa PA. Hanapin yung PA, nasa left leg. Ano? Nasa dito. No? PA. And then, bababa ako. That would mean that I'm going to go down from the center line up to yung depth ng HA. Okay. So I will have PA plus, okay, bababa plus ano, uh, uh, rho A times HA, uh, rho A times G times HA. And then bababa uli ako hanggang doon sa point 1. So that would again be preceded by a positive sign. And the fluid under consideration is mercury. So I will have plus rho Hg times G times uppercase H. Okay. So tapos na ako dyan sa left leg. And then I'm going to slide my finger up to towards the right leg at point 2. So nasa point 2 na ako. And then gagawin ko is I'm going to proceed upward, so that will be preceded by a negative sign. Okay. So that I will have the equation minus rho sub B times G times HB. And then that would be equal to PB. Okay. So, ganyan ang nangyari sa equation na yan. Yan, PA plus rho A plus G plus H sub A plus rho H sub G times G times H minus rho sub B times G times HB is equal to PB. Okay. And then rearranging the terms and fighting for the equation of the pressure difference, notice class na parehas ang nakuha natin, no? As when we use the long cut method. So ito yung long cut method at ito naman yung shortcut method. Okay. So, which do you prefer now, class? Would you adhere to the long cut method or would you like to use the shortcut method? Sa shortcut method, kahit mini-mental mo na lang yan eh, no? Okay. Okay. Dito kasi sa long cut method, kailangan pang indicate ka ng point 1, point 2, P1, P2, no? Hindi na. Dito, hindi na eh. Shortcut na yan. So, kung if you're going to ask me kung ano yung practical applications of this, when I had my OJT some years ago, or some decades ago, tagal na yun eh.